Well, good morning, everyone. Okay, moving on over. What we're doing today. So we've been working with systems of equations all week, and now we're going to do systems of equations with three equations or three variables. And we can use any of the methods we've had, multiplication, elimination, or substitution. Although with three variable systems of equations, it's usually best to use elimination. So let's use those methods and use them to solve systems of equations in real world application problems. Ooh, all right. So what you need to know. So you got to pick two equations, right? Pick two of them. See if you can eliminate one of the variables. And then you get a new equation. And then select a separate set of two, so not the exact same set, but a separate set of the two that you just got. Get another one, and well, in this case, it looks like they call it equation B, so you have to eliminate the same variable from two different sets of the equation. Then use that, A and B, to solve the system for one of those variables. And lastly, substitute your answers in from the third step into either your original equation or whatever. You can I think you can also use one of the equations that you ended up getting later on, which is okay. I mean, I've said that you should try to avoid that, but in this case, it looks like we might need to end up doing that a little bit more than usual. So let's go ahead and get started. Okay. So I have this one right here first, and it looks like we're going to need to pick some variables to get out of there. Okay, let's see. And this one's it can be pretty difficult if you're not really sure, if you're not very strong with your systems of equations. And this one's going to take a lot of writing. But before that, let me go ahead and look at these. Now, I'm going to just look at the variable that I would need to eliminate. And it looks like y would be one of the easier ones to eliminate. So I'm going to eliminate y here, because in this case, they're already the same. Right? I have y and y right here. And if I need to pick a separate set, so anyway, there's my first two and my second two, like that. Okay, so I think this first one can stay the same. 2x minus 6y plus 9z equals -8. Now I'm going to multiply this bottom one by 6. So times it by 6. So that's going to be 30x times that by 6 plus 6y plus 2 times 6, that'd be 12z. And here we have 60. So again, double check these. Make sure you got all of them times by 6, because it is pretty easy to make a mistake on some of these. All right, so it looks like we are ready with this one. Excuse me. Oh my goodness. All right, let's go ahead and continue on. So y cancels out, which is good. That is what we want. We're trying to get these to eliminate. And then let's see, 60 minus 8, so this would be 52. And there we go. So that's about as close as we can get with that one. Now we got to pick a second set. So again, this is like they call it set A. Now we're going to look for the set B. And I am going to need one of these to be negative, right? Because if it's positive y, when I combine them, it's going to make 2y, and it's not going to eliminate. So not only do they have to be the same letter, the same coefficient, but they also have to be opposites. So let's see if I can take care of it like, no. I'm going to move this a little bit more. And like I said, I'm going to make one of them negative. So I'm going to times this bottom line by -1. So first one, I can probably leave it the same, 5x plus y plus 2z equals 10. And then everything on this one's going to have to be reversed just because I'm multiplying it by -1. Negative y plus 8z. And then 28 would be positive because it's times by -1. And double check to make sure I changed all the signs, which it looks good so far. Now I'm going to go ahead and combine these two. So that'd be 2x, and y cancels out, which is good. That's what we would have liked to see. Plus 10z and 38. Now we got to pick two of these. We got to take both of these and pick one of the variables to basically drop out. So we are going to need to put them in together somehow. Now, if I try to eliminate z, that's going to be kind of hard because 21 and 10 have no common multiples. I think maybe 210 is the only one I could get, but I'd have to multiply this by 10. Multiply this by 21 and multiply this by 10. So I'm not really sure if that's going to work out. I'd like to try 32, or get rid of this. Sorry, excuse me. Get rid of this number here. But I'd have to multiply this side by 32. But I'm thinking that's going to have to be the way it is. Just because, again, if I can change one of them, that's better than changing both of them. So I think that's what I'm going to do. So I'm going to need to times this one by, let's see, 16. I'm probably going to have to multiply everything by 16. So 2 times 16 is 32. X times this by 16, that'd be a little bit easier, 160. Z equals, and I don't know this one right off the top of my head, so let me go ahead and grab a calculator just to make things move smoothly. 38 times 52. I'm sorry, not 52, 38 times 16. Wrong number. So that'd be 608. Now I'm going to get rid of the x here. So that means I'm going to move this here. But I'm going to times this by -1. So 32x. But that would be a negative because I have to make it into a negative now, minus 21z equals -52. Double check my signs, make sure they are switched to the right sign. And there we go. It looks like it's ready to go. Let's see, this cancels out, which is what we wanted. That was our goal. And here it looks like we get negative, let's see, 160 minus 21. It'd be 139 is what I believe, but don't want to make any mistakes here. And then 608. And minus 52, that'd be 556. Now I need to continue dividing them until we get one of the numbers. Now, okay, that should be z. I almost, looks like I need to cram that z in there. So z equals, and let's go ahead and divide that out. Divide by 4, so it becomes, oh, nope. It looks like we get -4 or just 4. Okay. This one should not be negative. I'm looking over the whole thing, and that one should not be negative. Just because of the way I lined it up, maybe I thought it was 16 minus 21, and for some reason I just thought that was the bigger number. So, all right, yeah, something doesn't look right. Don't be afraid to back up and check it out again. Now we're going to have to take our z and plug it into one of our functions. Now we got to be really careful with these again, because if we make even the smallest misstep, everything after that's going to be ruined. So I'm going to take one of these here. I'm going to take this one here just because it's right there also. And I'm going to plug it in to plug in z. So that's 10 times 4 equals 38. So plug it in there. And again, hopefully I didn't make any mistakes. Usually I tell people not to do this because it introduces the, because you're using something that you modified, and if you made a mistake on this, then this isn't really going to help out. But we're just going to have to be really careful and have faith in our work. And let's see, in this case, it looks like I'm going to go ahead and minus 40 from both sides. And I get 2x equals -2. So this would mean x equals -1. Whew, okay, there we go. Now we got the second one. Now we're going to have to plug it in to get the third one. So let's pick one of these, and as I always say, it's best to go back to the originals. So I'm going to go back to the original, and I'm going to pick 2 of these. Now, since I'm looking for y, these 2 are already solved for y, where if I use one of these ones here, y is probably not going to be solved for, or at least by itself. So I'm going to pick one of these, and I'm going to pick this one here just because it looks like it's got the smaller numbers, and I'm going to plug in my z and x value. So 5 times -1, because I got it from down here, plus y. Now that's what we're looking for, so we don't have that. 2z, and z is 4. So let's see, -5 plus y plus 8 equals 10. All right, now we got to subtract 8 minus 5. So that's going to be y plus 3 equals 10. And I'm going to have to minus 3 from both sides. And that would give us our y value. Y equals 7. Okay, and that looks like that's about it. I'm going to move this over here because I'm going to need to write my ordered pairs. well, in this case, it's an ordered triple. So for my ordered triple, I might have to go in alphabetical order. So X, Y, and Z. So X, Y, and Z gonna look like that. So -1, 7, and 4. Yeah. Yep, that was quite a bit of work. Ooh, just gonna. Ooh, spend a little bit more time waking up. I don't know why it always takes that long. I'm just not a morning person, I guess. Okay, whew. There we go. So that was another tough one. All right, so let's go ahead and start working on these two here. So now we have to decide which variable are we going to cancel out first. So again, we have a choice. We can either do x, which x looks like a pretty good one because all three of these numbers can become either 12 or, well, let's see, they can either become 12 or something else. I'm thinking these two here and these two here. So top and bottom, and then the bottom and middle, because I would only have to triple this one to get to 6, and I would only have to double this one to get to 4. So again, if you think ahead, you can pick smaller numbers to work with, better numbers to work with, numbers that you might be more familiar with, and smaller numbers are just, again, easier to work with. So I'm gonna stick with it that way. So let's go ahead and I'm gonna work on these two here. So grab these two, and I'm thinking I'm gonna multiply this top one by -1. Now, even though I did say I like to change the fewest things possible, if you're changing two things on the same equation, it'll still work, but okay, so in this case, all I have to do is just reverse everything. But if I had to reverse and multiply, like the bottom one, we're offering more chances of something to go wrong. So it's just like anything, you know, if you plan something and the more things that you change, the higher the chance of something going wrong will be when you make something more complicated. All right, double check it, make sure you reversed everything, which in this case I might have missed this, which again, this is why it's important to be careful and meticulous in your calculation on this one here. And again, don't be afraid to double check yourself. I know even though you feel like you're a good student, everyone in this case has the opportunity to make a mistake. All right, so now for this bottom one, I'm gonna multiply everything by 3. So if I had to multiply everything by -3, then again, you might forget a sign or something. So in this case, I'm gonna just split it. And you can do this however you want. You could leave one the same and change the bottom one and then double check it, but I'm gonna sort of work on it and there are more than one way, okay? There is more than one way. It's not something that you can, oh, no, I had it right. I don't know what I was thinking. There's more than one right way, so don't get into this habit of thinking you have to follow my steps, all right? You can choose any of the variables to get rid of first. And I'm not changing the sign on this one. $85 times 3, so that would be 15 plus 204 or 240. So 240, that'd be 265. And I'm gonna double check that just because I should have grabbed a better calculator. 85 times 3. Okay. And like I said, don't be afraid to double check yourself. 255. 85 times 3. Make sure I punched it into the calculator right also. 255. All right, looks good. Now let's see what we get from this. So again, we canceled out the x. So 4 minus 21, or 21 minus 4. And then that'll be 214 here. Now I'm going to go ahead and take these two here. And I'm going to think, let's see, I'm going to have to double this bottom one. So just so people know where I'm bringing them from. So again, I'm going to multiply this bottom one by 2. Now this top one's going to stay the same, it looks like, but I'm going to multiply it by -1 again. So, and I'm just going to basically copy this one here just to keep things easy on myself. It's usually finding the first variable that's the hard part. After that, it's not so bad to find the other one. Oh, God. Oh man. All right, so this would be, oh yeah, I'm doubling it, so I'm gonna have to double everything, or, oh man. Okay, no. I grabbed the entire wrong equation. This is why I have these lines going everywhere. So these lines also help me, and I don't know why I picked the middle one, but we need to pick this top one and times it by -1. So take that top one, -4x plus y. But again, it's going to be multiplied by -1, so it's going to be -y plus 3z equals 45. Come on. I said 45. There you go. Now double check the signs. Make sure all the signs are flipped. All right, not bad. Ooh, okay. Now for this bottom one, so again, follow the line. So double it. So everything's got a double. So we're not switching the signs, which is good because it only gives me one thing to have to worry about. So I'm just doubling everything. So 85, that I think that'd be 170. Okay, now let's see what we have left over. Oh, well, let me double check it, make sure everything was doubled, which looks okay to me. All right, so this cancels out, which is good because we got to cancel x out on both of these, right? Because if we canceled out like x on this one and y on this one, that's not going to do us any good. We have to make sure we cancel the same variables. So on both of them, they have to cancel x. Or any of the other ones you choose. So -15y. And let's see, -19. Now I'm second guessing myself on some of these easy ones. 19z. And 45 subtracted from 170. All right, that'll be 125. There we go. Now, we have to decide which of these are going to be the next ones to get rid of, let's see, 19 times 2 isn't going to work. And then 15 times, well, shoot, if I'm going to get rid of y, I'm going to have to multiply quite a lot. I was kind of hoping that we would be able to just double 19 or something. Maybe I made a mistake somewhere. No, that looks pretty good. Okay, it looks like we're just gonna have to bear down and multiply some of these by huge numbers. All right. All right, I thought I had to sit here and think about it for a bit, but it looks like, again, we are just gonna have to do this. So for this one here, I'm gonna have to multiply everything by 15. And so let's go ahead and take care of that. 15 times 17. And then 36 times 15. And now 214 times 15. $3,210. Now I'm going to have to take this bottom one, or this one here, and multiply it by 17. But now, if I did that, I would have to probably change one of these. So I'm going to have to, because if I just multiply it by 15 times regular 17, then it would be the same thing as this, and I want them to be opposite, same number but opposite sign. 15 times 17. There you go. And negative times negative would be positive, so that would give us positive 255y. And now we got to check our sign, negative times negative. So in this case here, again, I can't really make this easy on myself. So we're just going to just be ready to do a little bit of extra work. 19 times 17 is 323. Z. Okay, and now last one, 125 times 17. Okay, now we had to add these together here. Since we tried to make the y cancel out, let's go ahead and put these together now. So 323 minus 540. And this is negative 217. And let's do this one, 3,210 minus 2,125. And it looks like I get 1,085. Now I have to divide this by 217. And we get a nice number. Oops, almost forgot the z again. Z equals 5. In this case, negative 5. My calculator cannot do negatives as well. So I have to kind of keep my negatives in my head, or keep track of the negatives also, because it is really easy to lose those negatives, especially if you're like me and you have a calculator that does not keep track of negatives. It's just a very simple one. All right, but that looks good so far. So we have our first part. And that was quite a bit of work. Now, we can't plug this z into any of the originals because I'd be missing x and y also. So that means two others I'd be missing. So I'm gonna have to pick one of these that I worked with because these are the only ones that have x out. So if I plug it in here, that'll give me the other one, basically. So which one looks like it's the easier one to work with? And again, I'm not really sure, but I'm just gonna go with this one right here, just because it's the one right here where I have this empty space where I can write it out. So negative 15y minus 19 times negative 5. Because now I know that z is negative 5, I'm going to plug that in there. And let's go ahead and start evaluating it. So 19 times negative 5. And again, I'm pretty sure I know what it is, but I'm going to just not play, not risk it. So let's see. That'd be positive 95. Yep, that's right. Equal 125. And now I'm going to have to do a little bit of work on here, minus 95 on both sides. Minus 95, so that'd be 30. And this one looks pretty good as well. Negative 15y equals 30. And I'm running out of space, so I'm going to wrap this one up. Y equals negative 2, because negative 2 times negative 15 would be positive 30. So I just got to ask myself, what would fit in there to make sense? And there we go. We got z and y. Now we got to go back and plug those two, the z and the y, into one of the original equations. So let's see what we can plug it into. So we don't have x. So x is the one that's missing. So let's try to find one that's easy to solve for x, which I think is this one here. 2x minus 7y, which 7 is negative 2, minus 11z, which z is negative 5. Okay, and then make sure I'm putting all this in the right place. And that comes out to 85. So let's go ahead and start evaluating this, evaluating our multiplication so that we can solve for our x value. And in this case, what do we get? 55. Pretty sure that's 55. There we go. Combine these two together, so that'd be 9. And so 5 plus 4, 5 plus 1. Now we got to minus both sides. So minus, and we get 2x equals, let me go ahead and take that subtraction and work that out. I should have grabbed a better calculator than this one. And it looks like we have 16. Okay, now we should be able to get our x value. And yeah, these just require a lot of writing. That's just the way they are. So a number times 2 that gives me 16 would be 8. So let's go ahead and put them in order. So x, y, z. All right, there we go. Now these do take a little bit of time to work out. Oh man, I don't know if we're gonna have, well, we have tomorrow. The thing about it though is that because the internet was out yesterday, that really throws off the entire lesson plan, because now I have to push everything back a day. This would have been better to have done, break it into 2 lessons. It's only 5 problems. There's a little bit more where it says applications, but I'm not even sure if we're going to get to that this week. And I've already made the week 8 packet. If they let us make the packets later on in the week, that might be a little bit better because, like in this case, it would have given me an idea. I could have made this, but I already have the next 3 or 4 lessons lined up already, so there's no way for me to, there's just no way for me to change it now. They're already out there. So I guess we're just gonna have to skip a few of these. Maybe we'll work on this tomorrow instead of what I was originally planning tomorrow. All right, so these are some pretty big problems and they take a bit of time to work on, so we probably only have enough for 1 more. Okay, so let's go ahead and get this one here. So let's look at what variable would be the best to get rid of. Now you might be thinking of x, because I have 5x on top and 5x on bottom. So that would be an easy way to get rid of x. But the thing is, on there, I would have, I'd have to get 45 in either the top and middle or bottom and middle. So I'm not really thinking x is a good idea because I'm going to have to change more than one of them. All right, let's look at y. So with y, if I had to make all of them 12, I could easily do that. And with z looks like it has the lowest ones because if I wanted to get these 2, I'd only have to multiply this one by 4. And if I wanted the top and middle, I would only have to multiply this one by 8. And again, there's no wrong way. You could do it this way, you could do it that way. You could try to get x first, you could try to get y first, you could try to get z first. But in this case here, I think I'm gonna just go with z. It's kind of a toss-up. It's not really so much easier to where it would just be obviously do that one. So it's, again, this one could go either way. I think any of them would be easy to find. So I'm going to multiply this bottom one by 8. Which means I can, since it's already an opposite sign, I don't have to multiply any of them by a negative. Okay, so let's go, and I also get to keep my numbers kind of small, but again, if you remember the last one, when we were down to the first, or when we were down to the what we call the A and B formulas, it still required a bit of work. All right, so that one, everything is the same, and for this one here, we're gonna have to times everything by 8. So 9 times 8 is 72. And let's see, this would be 4 times 8 is 32. And we're not changing the sign, so that'd be 8z. Yeah, okay. And 8 times 6 is 48. Put the 10 back on. So 4 times 6 is 48, but then times it by 10 to get that 0 back on, so you get 480. Now double check the signs and make sure I'm not losing any signs or anything like that. And I think we're ready to get this first one eliminated. All right, so 72 and 5 would be 77x minus 36y. And again, I'm just going to go ahead and, now they're both negative, so when I do this on my calculator, I'm going to have to treat it like I'm just adding them. So 59 plus 480, and that would be 539. Now again, I do say my calculator does not keep track of negatives, so I got to keep an eye out for these things. So that one should have been a negative 539. Okay, now I need a second pair of these. So I'm going to go ahead and take my top one here. Now again, I picked this one here so I wouldn't have to change that many things. So on this top one, I'm only going to have to multiply everything by 4, and the bottom one I can leave it the same. So again, I want to get through this changing as few things as possible. 9x minus 4y. Oh wait, I said I was going to multiply everything by 4, so oops. So multiply everything by 4, and that's why I draw these lines with these little things. So if I make a mistake, I can easily tell what I did, right? I can follow my own backtracking. 36x and times that by 4, you get 16. 16y. I don't know why I'm getting all spacey all of a sudden. Probably brain overload. And this would be negative 240. All right, double check it. Make sure I quadrupled all my numbers in the right way, and check my signs. Make sure all my signs still line up because I didn't change anything in the signs. Which is good because now if I don't change anything, then there's no possibility of it going wrong. All right, so let's go ahead and start working some of this out. So the z cancels, which is good because now we have one less number to work with, so that'd be 41x. And I really, really hope we get something that's easy to work with in this case, minus 14y, and z cancels out. So this is the part I'm gonna need the calculator with. Now I'm gonna put the negative first so I don't forget that it's a negative, because again, my calculator cannot calculate negatives. So I'm gonna just add it like it's a plus, 287. Now we're gonna look at it and see what we can, see if there's any easier ways we can do this. So 14 times, okay, let's see, can I times anything by 14 to get 36? 14, 28. What is, okay, what is that? What is that? 28 plus 14 is 42, not 36. Darn, I was hoping I could only get away with changing one of them. All right, I think we're going to have another case of having to multiply them by really big numbers to get rid of them. Now, we do have a calculator, so this probably isn't going to be so bad. But we could make a chart of numbers where 14 and 36 can meet up at, and then pick the lowest one. So like you just count by 14 and 36, and then see what number they have in common. There's another way to do this too. But but that would take a long time to teach that method, because in order to teach that, you would have to know about least common multiple and how to find them. So I guess we're just gonna have to do this. So I'm gonna have to multiply this top one by 14 and multiply this bottom one by, now I'm trying to eliminate the y, so I'm gonna multiply this by 36, but I don't want them to match. So I'm gonna make one of them be the negative, and I'm gonna just pick this one. Okay, so again, if we have a good calculator, this shouldn't be a lot of work. 77 times 14. Okay, make that x a little bit better. And then 36 times 14. Oh, and this one should be negative as well. it should be negative because I got to switch the sign. So maybe switch the sign on this one because negative times negative is positive. So I'll take care of that. 36 times 14 is 504y. And let's see, 539 times 14, 7,546. Now I got to multiply all of these things by 36. So 36 times 41. That's going to be 1,476x. 36 times 14 is negative 504 because it's a negative times a positive. And again, they have to be opposite because that's what we're looking for. And last one, times 287, which it's going to be negative. And this is going to be 10,332. 332. And again, even though it's a big number, most of this work is being done by the calculator, so it's not really as tough as it would be. Now, y cancels out, so that only leaves me with having to work with the x value and the regular number. So let's see, 1476 minus 1078. And I managed to get 398x equals, now let's go and do this one, 7546 minus 10332, and I get negative 2786. Now I know my first number is going to be negative, so I'm going to have to divide that by 398. And it looks like we get negative 7. All right, there you go. So like I said, yeah, that's a bit of work, but it's usually only for the first one. Once you get the first one, from there, it's pretty easy. You just sort of follow what you normally do, but you just got to do it twice is the thing. And again, I'm so far having pretty good luck just using this one, so I'm not going to overthink it. I'm just going to just drop x right into there. 41 times negative 7 minus 14y equals negative 287. All right, so everything's the same. I just dropped in negative 7 in there. So 7 times 1 is 7. And 7 times 4 is 28. So 247 minus 14y equals. Something is kind of a bit weird here because I have a 287 on both sides. Now if I add 287, I get negative 4y equals 0 because both sides got their negative 287 canceled. So what do I do with this? What number times negative 4 can give me 0? Well, in that case, we're going to have to use our zero product property, and y is equal to 0 because negative 4 times 0 is 0, so that means y has to be 0. Or I could divide both sides by negative 4, and 0 divided by negative 4 is still going to be 0. So anyway, there we go. We got that one. Just one more of these things here. And let's see, I'm going to have to pick one of these to put it into. Which one is it going to be? So I have x and y, so that means I'm looking for z. So I'm going to get the one that z is by itself on. And I don't know if, well, no. I'm not going to do that one. I'm going to use the bottom one. And again, it's a toss-up. It's not like one is way, way easier than the other. But I'm going to see if I can get away with not having to make the z negative. All right, so let's go ahead and plug it in. So 5 times -7 plus and 2y, so 2 is 0 plus 4z. Now I could have just left out the y like we did in y standard form graphing. So if you remember standard form graphing, we just ignored anything that had a 0 put into it, any of the terms with a 0 in them. But oh well, let's just keep going. -35, and that's 2 plus 2 times 0 is going to be nothing. It's going to be gone. 4z equals -47. And now I'm going to have to add 35 to both sides. And in this case, I think it's 12. Now it's going to be -12 because the negative is a little bit bigger. And again, I'm just I'm just going to double check that. So 35 divided by, sorry, minus 47. Yeah, okay, it is -12. And then divide both sides by 4. And z is equal to -3. Okay, there we go. We got all 3 pieces. So -7 is x, and then y is 0, and z is -3. There you go. And that's it for that one. I'd like to do one more, but I know these problems each seem to take about 20 minutes, so I don't think there's going to be enough time to do another one. We still have tomorrow. We still have Friday, but I still like having Friday set aside for other things as well. So maybe we'll just finish the other 2, and that'll be it for tomorrow. And that would also leave one of the things in your packet. So the applications. So there's one of them that says more applications for linear equations. And there was another one too. I think it's called, well, this one here has applications in 3 variables, I think is what it's called. So the word problems to both parts. Unfortunately, we may not get to both of them. So I don't know, we'll probably just leave those ones blank if we can't get to them. But we will have a lesson tomorrow. We're going to have to finish this one and maybe do 1 or 2 of the word problems, although I might just end up removing those. If I don't get to them, I'll just remove them. So anyway, there we go. I guess that'll be it for today. Let me get back to the this screen here. I'm going to take a screenshot, and I'm going to use this for my attendance. Just so that way, if in the future there's ever anything that goes missing, I'll have at least this to go with. Anyway, I think that's everybody. Everybody, the chat has been, I don't think anybody showed up and left or anything, so I think this is everybody. Anyway, I guess that's it. Thanks. That's it for today. Don't forget, we are gonna have a little bit of class tomorrow, so that'll be it. Bye bye for now.